2, 1, go. So, good evening, everyone. This is the discussion hour for the course Essential Mathematics for Machine Learning. So, all of you have enrolled for this course, and I'm Radhika, and I am studying at IIT Kanpur. So, I am pursuing PhD in physics, and I will be your teaching assistant for this course. So, okay, sorry, actually, my camera is placed a little bit different location. So, sorry, I will keep this in mind. So, now we will look at some of the problems from week 0. So, this is assignment from week 0. This will not be graded. It is just some mathematical prerequisites that you should be knowing before you join this course. So, we will discuss some of these questions from the week 0 assignment. So let us start. So this is the first question. This is a basic question on limits that we have. So the question is, question number 1, we have limit x tends to 2 of x squared minus 4 divided by x minus 2. We need to find out this limit. So let us start. So limit x tends to 2 of x squared minus 4 over x minus 2. Now we can factorize the numerator. So we will factorize the numerator as follows. It is x minus 2 times x plus 2. Now this factor will cancel out. So we get limit x tends to 2 of just x plus 2, and this turns out to be equal to 4. Now there's another way in which you can solve this. So typically when the numerator and denominator go to 0, let's say if we put x equal to 2 directly in this numerator, so that will be 2 squared, that is 4, minus 4, which is 0. Similarly, in the denominator, if you put x equal to 2, we get 2 minus 2, which is 0. So if you have limits of the form 0 by 0, then we can use what is known as the L'Hopital's rule. So in this, what you do is you differentiate the numerator with respect to x and as well as the denominator with respect to x. So in this case, what we get is limit x tends to 2 of the given function is the same as limit x tends to 2. When we differentiate the numerator, we get 2x. When we differentiate the denominator, we get simply 1. And this gives us limit x tends to 2 of 2x, which is 4. So we get the same result. So the answer to the first question is B, that the limit exists and it is equal to 4. Now let us proceed to the next question. This is a question. Yes? 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 See, when we are doing right now, this is limit x tends to 2. It is not x equal to 2. We will not set it right now. So this is x is moving closer and closer to 2, but it's not exactly equal to 2. So in that sense, we can cancel out that factor. We are not substituting x equal to 2 right away. Yeah. So that's a good point. So we can cancel only when it is non-zero, and in limits, we do not put the exact value of it. It is limit x tends to 2. So that means x is moving closer and closer to 2. So now the next question is, yes, there is a proof is there, but we will not really discuss the proof right now. Maybe in the next class, I will work out the proof. Yeah, this actually works for two kinds of forms. So it works for 0 by 0 form as well as for infinity by infinity form. So these indeterminate forms in these, no, not in 0 by infinity. No. You need to convert it somehow, maybe to 0 by 0 form or infinity by infinity form. Now we will move to the next question. This is a question on matrices. So this is question number 2. So we are given a column vector U and we want to find out this particular matrix, which is identity minus 2 times U into U transpose. So let us first find out U times U transpose. So this is as follows. This is U transpose. So this matrix turns out to be so this is the thing, and identity matrix is as follows. So in the NPTEL assignment portal, if you go, so the identity matrix is written down a little bit in a wrong manner. So this is the correct identity matrix. You should remember it. So if you look at your assignment, there is a typo. So now if we do I minus 2 times U transpose, that is equal to minus 2 times U transpose, and this comes out to be like so. So that means option B is the correct option. Why? So all the values are negative. Yeah. So now we move to the next question. This is a question on finding the solution to a system of linear equations. But not just that, they want us to use the Cramer's rule. However, this is an MCQ question. It doesn't matter whether you use Cramer's rule or whether you just guess it, whether you just plug in the values and find out the answer. So in that sense, it doesn't really matter. But since they have asked us to use Cramer's rule, we will use Cramer's rule. Now, before proceeding, let us write down what Cramer's rule says. So, according to Cramer's rule, if we have a system of equations, means for solving linear equation system of linear equations, right? I don't know of any rule in that. That is a nice humorous joke, but here this Cramer's rule is a real thing to solve any given system of linear equations. So you can write down the given system of linear equations in the matrix form as follows: Ax equal to b, where A is the matrix of the coefficients, x is the column vector of the unknowns that you want to find the solution to, and b is the constant column vector. So if this is the solution, the given system of equation, then the solution is given as follows, where AI is nothing but the matrix, so ith, sorry about that. So AI is a matrix in which the ith column of A is replaced by the column vector B. So this is AI. So this is the Kramer's rule and we will use it to find out the solution. Now if we look at all the options, then the solution for X is equal to 0 for all the 4 options. So there is no point in trying to find out the solution for X. We should instead we will focus on finding out the solution for Y and Z, because solution for Y and Z will determine which of these options is correct. So solution for Y by the Kramer's rule is determinant. First, let me just write down the A and B matrices that will make shadow is coming. Okay, let me try and fix it. Now, is it better? What square shadow? Actually, I'm not able to see any shadow. Let me just check. Give me a second. I see. I will try and fix this in the next time. Right now, I'm not able to figure out how this thing is happening actually. Yeah, I now see it. Could you check in the YouTube live? Is it there in the YouTube live as well? Or maybe you could log it. Excuse me, actually this class is going on. This is supposed to be an official class which will be recorded and it will be submitted to the NPTEL officials. Actually, you go to my YouTube channel. I will send you my YouTube channel link. Just give me a second. You should behave yourself. As I mentioned, this is an official class and it is being recorded and it will be submitted to the officials at NPTEL. So I have provided the YouTube link in the channel. This is the link of my YouTube channel. You go there and you will see live video. Actually, I'm not sure how to send the link of the live stream. If you click on this, you will go and see the live stream. Okay, so in that case, if you people are facing a lot of trouble with this, I would suggest that you could probably watch in the YouTube. I will try my best to fix this issue from the next time. Okay, so we were at Kramer's rule and this is Kramer's rule. So let me write down the matrices A, X and B for you so that it becomes easy. So okay, I will fix this. You focus on the screen, that is more important. So this is the matrix A. This is the matrix of coefficients of X, Y and Z. So, and the X column vector is the column vector of unknowns and B column vector is the column vector of these constants right here. So this is B. Now solution for Y from our Kramer's rule is given as follows. So we will have determinant of AI, that means first column remains as it is. second column will be replaced by this column vector B, that is 4, 1, -2, and third column will remain as it is. This determinant divided by the determinant of the original matrix A. So this, if we work out, this will come out to be -4. -1. So putting in the values, we will get I hope I'm doing all the arithmetic right. If somewhere I'm doing some mistake, you can point it. Oh, sorry. Yeah, thank you for pointing it out. So this makes it 70 divided by 35, which is equal to 2. So y is equal to 2. So that means option number C and D are eliminated. Now we need to focus on the value of Z to figure out which out of A and B are correct. So for Z, again applying the Kramer's rule. No, I'm finding out Y and Z. I don't need to find out X. Means one can in principle find out X also, but there is no need to find out X over here given the kind of options. Yeah, that is possible. So you can work out the value of X and cross check whether it is 0 or not. So this is -4, -1. And denominator will be 35. We just calculated it previously. So this makes it -15 minus 20 divided by 35, which is -35 divided by 35, which is -1. So Z is equal to -1. Thus our solution is Y is equal to 2, Z equal to -1. So the option which matches with this is option number A. So this solves this question. Next, we have another question on matrices. This time it is finding out the rank of a matrix. Now, rank is a term which, so rank of a matrix is basically number of non-zero rows in the reduced row form of the matrix. So we will apply row reduction to A in order to find out the rank. So what we will do is the operations that we will apply is R3 goes to R3 plus R1 and R2 goes to R2 minus 3 times R1. So this would give us, so now the next row operation that we will apply is R3 goes to R3 plus R2, and this will give us, so we see that the last row is 0. So there are two non-zero rows in this reduced row form. So thus we have rank equal to 2. So this is the reduced row form. Next, another question on matrices. This time we need to find out the determinant of, yeah, so that's what I said. Rank is the number of non-zero rows in the reduced row form of the matrix. So this is the reduced row form of the matrix. We see that the last row is 0. So we have two non-zero rows. That means rank is equal to 2. So moving on. Here we need to find out the determinant of 2 times this matrix. So first let us find out the determinant of the matrix A itself. So determinant of A, sorry, and why so? Yeah, but this order of problems is not set by me. This has been set by the NPTEL, the course that has been set by. So yeah, means I am just discussing it in the order that is already given in your portal. Yeah, so determinant of A will be, just check if I'm doing the arithmetic right. So this is 1 plus 5 and then 2. Okay, so I will try and fix all these technical issues. Okay, so this is the determinant of A. Now, determinant of 2 times A would be 2 cube times determinant of A. Why cube? Because this is a 3 cross 3 matrix. Had it been a 2 cross 2 matrix, this power would be 2. If it would have been 4 cross 4 matrix, this power would be 4. So that means 8 into 14, and this comes out to be 112. So 112 is the determinant of 2 times A. So moving forward, trace of a matrix is the sum of diagonal elements. So trace is sum of diagonal elements. Now here the diagonal elements are 1, 3 and 6. So this turns out to be 10. So this is the trace of the matrix. Next we have a question on probability. So we are rolling a pair of dice and we need to find out the probability of obtaining a prime number on both of them. So prime numbers that are there, solution to what? Yeah, YouTube streaming, there will be a time delay. what is showing on the YouTube? No, I think it is correct. Oh yeah, something is happening. There is a latency. Every time I'm scrolling up and down, I think there is a latency. Yeah, there seems to be some latency in the YouTube, this thing. Yeah, I think I need to do low latency in the YouTube. I will try and fix this next time. Yeah, I can see there is some problem. Yeah, I realize this. So, I will turn off my camera and then turn on my camera. Let me see that. Okay, let me turn off everything. Okay. I I think now it is fixed. Okay, I think maybe I need to fix my network. Now YouTube is also fixed. Yeah, YouTube, some lag would be there. So now I think it is fine. Now we can proceed. So prime numbers in a die are 2, 3, 5. I'm sorry, there is some noise, I think. Okay, you should fix that on your end, or you should mute yourself. So prime numbers in a die are 2, 3 and 5 out of 1, 2, 3, 4, 5 and 6. So there are 6 numbers out of which 3 are prime. So probability of getting a prime on a single die is 3 divided by 6, which is half. So probability of getting prime, so this is for one die. For 2 dice, the probability of getting prime on both of them is going to be half for the first, half for the second. So half times half, which makes it 1/4. So this. Now we have a question on differentials. So no, because this is a question in which on both of them we want. So on the first die as well as on the second die. So first die and second die, both of them need to be prime. Had it been something like or either on this or on that, then you will need to do something like that. But right now, this is that on both of them we want the prime number. So we want the prime number on the first one as well as on the second one. Or if you want, you can actually, if you want to make things um like do it in a different way, you can actually list down, there will be 36 possible outcomes. You can list down those outcomes of getting. So now you have two dice, so you can have like a first die 1, second die 1, first die 1, second die 2, like this. Like this you will go. Sorry. Yeah, that is a good point. No, but then this is because you, either it can be a prime or it will not be a prime. So if we are to solve the question that find the prime either on the first die or on the second die, then we need to actually look at what the possible outcomes are there. So there can be situations in which there'll be this situation. So prime on the first die but not on the second die, prime on the second die but not on the first die, and prime on both or prime on none. So these are the four possible kind of situations that you can have, and there will be overlap in all those possible outcomes also. So let's say we have prime on both and prime on just one die, prime on the other die, and no prime. So then like four different kind of cases you will have over here. So if you want to work out the situation in which prime on either one of the die is allowed, then you can see out of these 36 outcomes, prime on just one die would be when you have 2, 3 or 5. So that means you would have 6 into 3, 18 such outcomes. So why I said 6 into 3 is because you have 6 numbers, 1, 2, 3, 4, 5, 6, and out of which 3 are prime. So when you have 2, then 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. These are all the options. Then you have 3, again 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Just give me a moment. My battery is low. I need to uh, plug in. Yeah, similarly, we will have 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. Now notice that uh, these cases also include prime on both die. So this 2, 2, this 3, 3, and this 5, 5. This is when both the numbers are same. Similarly, 2, 3, 2, 5, and 3, 2, 3, 5, and 5, 2, 5, 3. So uh, all these cases, 18 cases that I've written out here, they also include the case in which we are getting prime on both the die. So these are 18 cases, and 18 cases divided by 36, which is the total number of cases that you will have. So that makes it half. Hello. Yeah, in if you are want to exclude the ones in which both are coming, then you would need to do subtract 9 from this. So then that would be 18 minus 9, that is 9 divided by 36, which is 1/4. That would be the case in which you want to exclude the case in which both the both the dice are having prime numbers. Ha, only one of them is having prime. No, there are 9 of these cases in which 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of these cases in which uh, both the things are prime, and 9 cases in which only one of the thing is prime. 9 cases. See, I can highlight it for you. This case, this case, this case. So now you see 9. Yeah. So yeah, you can work out multiple kinds of problems based on this, on rolling one die, rolling two dice, rolling three dice, and you can work out the combinations that are possible. Next is a question on differentials. So we are given this implicit function of x and y, and we need to find out the value of dy by dx for a particular combination of x and y. So first let us write down the differential of this expression. So that would be 3x squared dx minus 2 dx y minus 2x dy plus 3y squared dy is equal to 0. Now let us divide throughout by dx. So that would give 3x squared minus 2y minus 2x dy by dx plus 3y squared dy by dx is equal to 0. Now we can take dy by dx common from two terms. And then finally we will get dy by dx is equal to and then putting in the value, so dy by dx at x equal to 2, y equal to 0 is sorry, I wrote wrong. So this is equal to 3. So this solves the question on differentials. Next we have a question on function. So we are sorry, what are you trying to say? Yeah, yes. In this equation, right in the starting, you want to put, then where you want to put? Here you want to put Okay. Okay, yeah, that can be done. But typically, you would want to first find out the expression for dy by dx or any differential that you want. You would not just want to put values right in the beginning. For example, if you put value right in the given function over here, then that would be meaningless because then it will all be constants. So you don't want to put, you should rather not put values in the beginning somewhere. You should wait, first find out the complete expression for your differential that you want to find out, and then you should put the value. So this is like we want to find out the value of dy by dx at some particular coordinate. You don't want to put the coordinate first and then try to see what is happening. So in that sense, the correct method would be to first find out this dy by dx and then put the value. Next, we have a question on functions. So we are given a function which is fx equal to mod x minus 3. So if we write out fx, so this essentially means that the function is x minus 3 for x greater than equal to 3, and it is minus x plus 3 for x less than 3. And if we draw the function, we can draw the function right here. So this is 0, 1, 2, 3, 4, 5, 6. So at x equal to 3 is the turning point. So if we draw the function, then so this is how the function will look. So now we need to find out which of these statements is true. So first statement says that limit x tends to 3 fx does not exist. This is a false statement because this limit exists and this limit is equal to 0. So this is x equal to 3. So you see that if you approach from the left side of 3 or from the right side of 3, the function moves closer to 0. So this limit exists and this is equal to 0. Fx is not continuous at 3. This is also a false statement. It is continuous. Why? Because continuity says that limit x tends to 3 f of x should exist and it should be equal to the value at x equal to 3. So this is the case. This is equal to 0. So the function is continuous at x equal to 3. The third statement says, sorry, I meant to say that this statement is not true. F is not continuous is not true. That means f is continuous. So f is continuous. The third statement says that f is continuous but not differentiable at x equal to 3. This is the only true statement. And why so? Because here the slope is equal to 1 and here the slope is equal to negative of 1. So the function is not differentiable. On the right hand side, you have a slope of equal to 1. On the left hand side, the slope of negative 1. So there is a discontinuity in the slopes of the function, that is the derivative of the function. So the function is not differentiable. Then we have the last question. This is a question on a pack of cards, and we need to draw 2 cards from the pack of cards without replacing the first card, and we need to find out the probability of getting 2 queens. So if in 52 cards in pack of cards we have 4 queens, so probability of getting 2 queens, when we draw the first card out, we have 4 options for getting the queen and total 52 cards. Then when we draw the second card, we only have three options for the queens because we have already drawn the first one as a queen, and then only 51 cards are remaining. So this is the probability, and if we simplify, this comes out to be 1 over 221. So this is the answer. So this completes our week 0 assignment. So we have discussed the solution to all the 10 problems that are there in week 0, and these are some basic, very elementary level high school mathematics which people should be aware of before taking the course. And if you're not aware of these concepts, then I would suggest that you try and revise a little bit of basic elementary mathematics. So this brings us to the end of today's discussion. Hello? Which two straight lines? Okay, so you want to understand this. This is just I'm drawing the function fx equal to mod x minus 3. So as I wrote down, this fx equal to mod x minus 3 is the function which is x minus 3 for x greater than 3. So this line right here is for x minus 3, and it is minus x plus 3 for x less than 3. So this point is 3, this point is 3. So this is how the function is. And if we draw line, then at 6 we have the value 3. So this is just I'm drawing the function. Okay. Okay, then see you in the next week for in the next class. Maybe I will do it from my lab, then you can see my lab equipment or whiteboards or something. Okay, thank you for joining. Bye. Okay, nice. Nice. Most welcome. Okay, bye bye. Yeah, sure. Thank you. Thank you. Okay. 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 Bye bye.